Okay, so we're talking today about the Hebrew calendar. We're going to focus mainly on the Rabbinical calendar versus the Biblical calendar. And I think the reason we'll focus mainly on the Rabbinical calendar is because I think that most people already have an idea of the biblical calendar, because that was one of the first things they probably studied in catechism. However, I'll play it very much by ear. If people want to go more into the biblical calendar, we can go more into the biblical calendar. We can go over the sources for Aviv. We can go over the sources for why we celebrate a month according to more or less actual observation. I'll say more or less because it's always not ever 100% clear. So I'll just let the group pretty much play it by ear. So give me feedback. Also if it's getting too long, if it's getting too technical, if you need a break, if someone wants to sing or dance, whatever you guys want to do, just let me know, and we'll play it, real informally and very much by ear. Okay. Also, I want to try to make it very interactive, so it's not just going to be hopefully, as I try to do on the internet, but there people can kind of hide behind the screens. Here no one can hide. So if there are questions or there are comments, I like to try to make it interactive, because that way it's obviously less boring. Also, since I was a teacher, I'm used to kind of making things interactive, almost like a classroom setting. I taught school in Israel, I taught school in America before I moved to Israel, etc., etc. So, with all that being said, we're going to start. So, what we really want to talk about today is the Rabbinical versus the Biblical calendar, and we're going to start with more or less the Rabbinical calendar. But before we even start with the Rabbinical calendar, we're going to start with the idea of a calendar. Okay. And I'll throw the question out to the group. What's calendar? Why do people even bother making calendars? Anybody?
Calendar is a measurement of time.
Okay, right. It's a measurement of time. I'm going to write some of this stuff down. It's definitely a measurement of time. Okay, what else? Why do people make calendars? To measure time. Can we be a bit more specific than that? What kind of time do they generally want to measure?
To get to work.
What's that?
To get to work.
To get to work? Okay, yeah, they want to get to work on time. Okay, so...
You know how to keep the appointed times of your money.
Okay, well that's certainly a reason.
That's the main reason.
To keep holidays. That's, I would say, one of the main reasons that many people set up their calendars, right, is to make sure that certain holidays fall in certain times, so they can keep track of the holidays. Keep Shabbat. Holiday Shabbat will fall at appointed times. And Yaakov, you said something? It's Yaakov, right? Again, I'm going. Jack. Okay.
The plant crops.
Crops. Okay. Right. So, okay. Anything else that anyone can think of?
It's also a record for the whole community to follow as a common timeline for everybody to understand what it is.
Good, right, very much so. It's a common record
Right.
of past and future events, we could say. And future events. Okay? It's basically, as Bill just said, it's a way to stay in sync with everything. So everyone can say, okay, well, this is going to occur on a certain date, and everyone knows that it's going to occur such and such, so they can prepare appropriately. Or this occurred on such and such date, and everyone knows exactly what we're talking about, right? So a calendar is very much it's a community thing, right? If I just lived off in the woods, I probably wouldn't so much need a calendar. I could just look up in the stars in the sky and decide, well, I'm going to plant the crops now, or I'm going to celebrate a certain holiday now, etc., etc. The second we get into an idea of a community doing a thing, then or doing certain things together, then we need some kind of record of this. And in fact, calendar, the word for calendar in Hebrew, does anybody know? We probably got to know this one. Okay, luach, right? The word for calendar in Hebrew is luach, and luach just means a chart. Okay, So for instance, in modern Hebrew, the word luach, if you're teaching school, luach just means a blackboard, okay? And if you have if you're working at a company and the time schedules will be put on for the workers will be put on a luach. So a luach just means a chart. So calendar is a type of a chart, at least in the Hebrew meaning of the word, right? It's something we write down to keep track of time. Okay. Now here's another question. Okay, what does a calendar generally want to attempt to synchronize itself to?
The season.
Okay, right, seasons, definitely.
And movements of the sun, the moon.
There we go. So Sam, you hit it right on the movements. Of heavenly bodies. Okay? Generally, okay, if you look at various societies, you'll see that their calendars were meant or were created to synchronize more or less the movements of the heavenly bodies in one way or another, and mostly we're talking about the moon, we're talking about the sun, sometimes we're talking about Venus in certain cultures, sometimes we're talking about stars in certain cultures, but generally the calendar is a way to artificially synchronize to the natural movements of the heavenly bodies, okay? And that's why And that's why a lot of times the calendar year is called the artificial year, and the actual year is called the natural year. Okay, so a calendar may say, okay, 1 year is, let's say in the Gregorian calendar, 1 year is a little bit less than 365 and a quarter days, and that's the artificial year. The calendar is saying every 365 and 20.24 something days, that calendar repeats itself. That's 1 year on the calendar. Okay? But if you actually go out and you measure the actual movements of the astronomical bodies, or if you gauge that actual year by the movements of the astronomical bodies, you'll see that it's not exactly the same. Okay? So you have the artificial year, which is the calendar year, and you have the actual year, which is the year that we could say that God, that Yehovah, places in the heavenly bodies. Okay? This is the calendar. And this is, for lack of a better word, we'll say this is Yehovah's year. Right? And the accuracy of the calendar can be judged by how close the artificial year comes to the actual year. Okay? A better calendar. Did you have a question? Oh, okay, I'm sorry. The calendar year, the artificial year, tends to replicate and predict and chart the year or the month or the day or whatever it's trying to chart. It's trying to chart some movement or some measure of time, and the actual year has its actual measurement of time. And the better that the calendar is, the closer that these two values are. Okay, and that's always been the struggle with calendars that use predictions of what the year is going to be. So you have a concept in just about every single calendar, except calendars that go by actual observation. It's called calendrical drift. Drift. Okay? Whereby the calendar says, again, a month is such and such amount of time, and the actual month is a little bit more, a little bit less. And the year is such and such amount of time, and the actual year is a little bit more or a little bit less. And why does this happen? And we'll talk about this in much greater detail. This happens because the motions of the heavenly bodies are not so simple as we would like them to be. Okay? The motions of the moon around the earth are very complicated. The motions of the earth around the sun are very complicated. The motions of the solar system around the galaxy are very complicated, and all these are constantly coming together in very, very complex interactions. Okay, so one thinks that for instance, if this is the sun and here's the Earth, that the Earth is just kind of going around the sun like this. But that's not really the case. Okay, first of all, the Earth is off the side a little bit. It doesn't follow a circular orbit. It follows an elliptical orbit. So I'll turn it this way. So it's not going in the circles. First of all, it's going in ellipse. Okay, and when it's going in the ellipse, it's not just going straight like this. It's actually kind of slowly spinning on its axis. Okay? And as it's spinning on its axis, it wobbles a little. And as it wobbles a little, the whole orbit kind of moves around as well. So you have instead of just a simple thing like this, you have this kind of very, very complicated motion of the Earth around the sun. And at the same time, the moon is doing that around the Earth. And the sun is doing that around the solar system, or I'm sorry, around the galaxy, etc., etc. So the motions are very complicated, and therefore, they become very difficult to predict accurately and exactly over long periods of time. So what's going to eventually happen is that we as human beings who set up our artificial year or artificial month or whatever the case may be, it doesn't only have to be a year, it could be a month, it could be a day. We're going to get a certain drift away from the actual. It's all right. It's not a library here, so you can talk. So I hope that the point is pretty clear. Any questions so far? Any comments? If you have a question now, my answer may be hold off, because we'll cover that in detail. Okay? What's that? Okay, very good. Good. Okay. So, the first thing we want to talk about is just very briefly. I want to go into some different types of calendars, so we can see what we're talking about. Okay. There are generally three main types of calendars among cultures. One is a lunar calendar. One is a solar calendar. And the third is, anybody know? It happens once in a while, but it's rare. Okay? Say again? Exactly. A lunisolar. A lunisolar calendar.
Lunisolar?
Yep, that's what they call it. Okay? Or in Hebrew it would be snow. It would be a luach, yapi, shimshi. Okay? Calendar of the moon and the sun. Okay? So basically, a lunar calendar tries to stay synced with the actual phases of the moon. A solar calendar tries to stay synced with the actual seasons of the year. And a lunar calendar takes upon itself the very challenging goal of trying to stay synced with both at the same time. Okay? And that's where we run into a lot of problems with the Hebrew calendar. And we'll see exactly what those problems are. Okay? Can someone give an example of let's start with the easiest, the solar calendar. Anyone know any solar calendars?
The one we use now is society.
Exactly.
Gregorian.
Exactly. The Gregorian calendar is a solar calendar. Okay? What's the attempt of the Gregorian calendar? Okay? If I say the date June 30th, okay, everyone can tell me that if we're in the northern hemisphere, then it's going to be hot outside or it's going to be cold outside. It's going to be hot outside, right? If I say October, what's today? Whatever it is, October 5th, okay? Everyone knows the leaves are probably going to be falling, at least in certain parts of the country, okay? And no matter what year, I can go 1,000 years into the future, I can go 1,000 years into the past, I can go 3,000 years into the future, 3,000 years into the past, and I know that October 5th is going to mean leaves are falling, and I know that June 30th is going to mean hot outside, right? And it's never going to change over time, because this solar calendar, the one we use, the Gregorian calendar, is designed to stay in sync with the seasons, which means in astronomical terms, in sync with the position of the Earth around as it orbits, as it revolves around the sun, orbits around the sun. Okay? Someone give an example of a lunar calendar.
The Muslim calendar.
Exactly. Good. The Muslim calendar is a classic example. Okay? Chinese calendar. Year of the dog and all this kind of stuff. You've all heard of that, right? Well, the years aren't the lunar part of it. They just mark the years, but the actual way the months set up is also a purely lunar calendar. I'm sorry, lunar solar. Okay, we'll just focus on the Muslim. Okay, so the Muslim calendar is a purely lunar calendar. Okay, what does that mean? It means that it doesn't. It tends to stay in sync with the position of the moon around the Earth, or the phase of the moon, to be more accurate. Okay, position of the moon around the Earth with respect to the sun, but it doesn't try to stay in sync with the seasons, with the position of the Earth around the sun. Okay, and if you have ever lived in any Muslim cultures, which I have, I've had the pleasure of living among the Muslims in Israel, not in their communities, but certainly sharing, unfortunately, the same land with them at this point. And you see that their main holiday, Ramadan, occurs at a slightly different time each year. In fact, each year it drops back about 11 days in the calendar system. Okay, so this year I think it's going on right now. Right now is Ramadan. In fact, Ahmed, whatever his name is. Right. Didn't he promise a big present for Israel, a big surprise for Israel on Al-Quds Day, which is the end of Ramadan. So Ramadan is now falling in October until the middle of October. Next year it'll end at the beginning of October. The next year it'll end in the middle of September, and then towards the beginning of September, and it'll fall back each year by approximately 11 days. Okay? Why? Because it's a purely lunar calendar. Okay? It doesn't make any attempt to stay in sync with the seasons. Okay? And I can look up the exact source. Actually, the Muslims originally had a luni-solar calendar, but Muhammad in the Quran, in certain verses, which are generally attributed to be some of the last verses he said before he died, he came out strongly against the idea of a luni-solar calendar. In other words, of adding leap months to try to stay in sync with the seasons. He said that it goes against God because it throws everything out of sync. Well, we know from the Tanakh and from the Bible that's just the opposite, right? We're required to keep the Passover in the month of the Aviv, and that can't drift to another season. But Muhammad, who had actually been doing that, or I don't know what he's been doing, but the Muslims had been doing that, actually came out against doing that at the end of his life, and that's why the Muslims to this day have a purely lunar calendar. Okay? So what is the advantage of a purely lunar calendar? Okay? A purely lunar calendar makes no attempt, as we said, to stay in sync with the seasons, but it makes a very precise attempt to stay in sync with the phases of the moon. Okay? So whatever the month is in the Muslim calendar, if I say it's the first of the month, then I know exactly what phase of the moon I'm in. Okay? I look outside on the first of a Muslim month, and I know that I'm going to have my more or less new visible crescent moon. It depends. In different Muslim countries, they do it slightly different. Okay? If I look out on the 15th of any Muslim month, then I know I'm going to see a full moon. And if I look out on outside on the 22nd of a Muslim month, then I know I'm going to see the waning quarter, and so on and so forth. Okay? Likewise, or just the opposite with the Gregorian calendar. Okay, as we said, if we say the date June 30th, we know it's going to be hot. We say the date December 15th, we know it's going to be cold, right? But if I tell you the date December 15th, and I ask you what's the phase of the moon, can you tell me the phase of the moon?
No clue.
No clue whatsoever. The Gregorian, the solar calendar, doesn't make any attempt whatsoever to stay in sync with the phase of the moon. December 15th can be a full moon, it can be a new moon, it can be a waxing quarter, it can be a waning quarter, whatever it is, and it changes from year to year, right? Okay? Now we get to luni-solar calendar. Okay? The luni-solar calendar makes the, as we said, ambitious attempt to stay synced to both these cycles. Okay? And in so, you basically have two kind of interlocking cycles. You have a approximately 29.5-day lunar cycle. That's how long it takes for the phases of the moon to go through one cycle, approximately, right? And you have an approximately 365 and a quarter day solar cycle, right? So you have the lunar cycle and you have the large solar cycle, and these cycles somehow have to work together, okay? And a calendar has to accurately represent where we are both in the solar cycle and where we are in the lunar cycle if it wants to be a luni-solar calendar, okay? And that's where the challenge comes in, and that's what the rabbinical calendar attempted to do. And in all honesty, did a very, very good job of it. If people think I'm going to sit here and bash the rabbinical calendar, they're incorrect. The rabbinical calendar was very, very brilliantly figured out, not by the rabbis. It was all the measurements and all the ways that the rabbis used to form their calendar were very much well known in the surrounding societies, in the ancient societies of that region. So it wasn't due to any necessarily genius of the rabbis per se. It was due to the general astronomical knowledge of the time, but the system that they did come up with and the system that they use is a very intricate and a very brilliant system, and it does its job relatively well. Okay, it more or less stays synced to the phases of the moon, and it more or less stays synced to the seasons of the year. Okay, but it doesn't do it perfectly. Okay, and over time, remember we spoke about the idea of calendrical drift. Okay, any calculated calendar, okay, any calendar that tries to make predictions or tries to go according to certain rules and create an artificial year is eventually going to be subject to calendrical drift, okay, because it's not going to be able to accurately model the exact movements of the heavenly bodies, and that becomes apparent over time. Okay, over time, the artificial measure of time, whether it's the year, the month, etc., is going to drift from the actual measure of time, and the little drift that happens each year or each month is going to compound over time, and then you start seeing noticeable differences, and then people start saying, well, this calendar is off, we need to make a change. Okay, and that happened in the case of the Gregorian calendar, right? I'm sure people know about the Gregorian and the Julian calendar, right? Up until I think it's 1582. Up until about 1582, the Christian world used the Western world used the Julian calendar. Okay, the Julian calendar predicted, or according to its calculations, has a year which is exactly 365 and a quarter days long. Okay, but the actual year, is a little bit less than 365.25 days. So what happened is that the Julian calendar kept on jumping ahead. Okay. And one second. Okay, right. The Julian calendar kept on jumping ahead. Okay, at any rate, it doesn't matter. The Julian calendar got off track, and at some point around the year 1582, if I remember correctly, the Pope decided, or he issued a papal bull, I think they call it. Isn't everything that's papal, isn't it already bull? So I don't know why. Anyway, he issued a papal bull, and they switched over from the Julian calendar to the Gregorian calendar, which was meant to be more accurate. Okay. And that was exactly because of calendrical drift. Okay, the Julian calendar had, that's why I have to think it out in my head again, whatever, it had actually fallen back, and then they added, if I remember correctly, 11 days, they added an extra 11 days, and then they instituted the Gregorian calendar, which was meant to be more accurate and have less calendrical drift. Okay? So any calendar, whether it's lunar, whether it's solar, whether it's lunisolar, if it goes according to some kind of predetermined calculation, then it's going to be subjected to calendrical drift. Okay? Let's contrast this with the calendar based on observation, right? Calendar based on observation, like the biblical calendar, right? The calendar that we use as Karaites, has no calendrical drift whatsoever, right? Why? Because we're not saying that we don't even have a concept really of an artificial year in a calendar that goes by observation, right? In the Karaite calendar, we don't say, okay, the year is 365 and a quarter days, and every 365 and a quarter days is now the new year, or every 365 days is now the new year, and then every fourth year we have a leap year, and it's 366 days, so we can try to stay synchronized. It doesn't even work that way at all. There's no predictions as to the cycles of the heavenly bodies at all. Instead of saying what the heavenly bodies, trying to predict what the heavenly bodies are going to be, we do just the opposite. We look up into the sky and we read we read off the information given out by the heavenly bodies, right? So it's the exact opposite of a calendar of prediction. It's the exact opposite of, say, the Gregorian calendar, okay? In the biblical calendar, no attempt at predictions are made whatsoever, okay? We look up, and when we see the new moon, that's the beginning of the month. When we see the Aviv, when we see the barley ripen to a certain degree, then that's the beginning of the new year, okay? And if things drift off, then the natural phenomena of the physical world will always correct us, right? Is everyone clear on that, or should I go into that a little bit more? Because I think this is a point probably most people know because of their knowledge of charism, but if anyone wants me to go into that a little bit more, then I will. Does anyone need me to go into that a little bit more, or is that's pretty clear? Okay. Okay? So that's the difference. We have on the one hand a calendars of prediction, whether they're lunar, solar, or lunisolar. On the other hand, we have calendars of observation, which in the case of the Karaite or the biblical calendar, whatever we want to call it, it's a calendar of observation, right? Is it a lunar calendar, is it a solar calendar, or is it a lunisolar calendar? The Karaite calendar or the biblical calendar?
Lunisolar.
Lunisolar, right? What sinks into the lunar cycles? What's that? To the lunar cycles.
It's a monthly cycle.
The months, right? When we see the new moon, that's what sinks into the lunar cycle. Okay? It's never going to drift off because I know I walk outside and when I see that crescent moon, okay, that's the beginning of the month. So it's never going to waver from that because that's what I'm looking for. Okay? What sinks into the solar cycle? Right? Which in our case is the Aviv, right? It's never going to drift off too much because if it starts drifting too much, okay, then Bill, 1 second, okay, I'll answer your question. Then the Aviv will get it back in line because I know that the beginning of the new year has to occur when I see the Aviv outside. So it'll never the beginning of the year will never drift off very far from the Aviv. Okay? Yeah. Question.
I think Jack had a question before.
Okay, Jack, question?
What that means, just to
I did.
Genesis versus.
I just have the whole question.
you resolve that, or is that still
What do you want me, I mean, I don't know how, this isn't.
Ask it, and worst comes to worst, as I said, I may say we'll talk about that later.
Yeah, we'll talk about that later.
Okay. Bill, do you have a question? Okay, that was it. Okay.
But the disadvantage of this calendar is that there are times we cannot predict when holidays are.
Absolutely, right? That's the disadvantage of the calendar of observation, right? If we don't know when we're going to see the new moon, right, as let's say the ancients did, and check it in 1 second, and now we know much better because the calculations are much more accurate. But if we don't know, then we can't say something like I will meet you on the we'll meet on the 15th of the third biblical month. That could fall out on, let's say, a Wednesday, or could fall out on Thursday, depending on when we've observed the moon, right? So there are a couple solutions to that. Okay, one solution in turn was suggested by Nehemiah, and I didn't really look into it myself, but he says that he claims as a possibility that there may have been another calendar that was used, which was actually kind of just a chronological calendar, okay, where it went day by day, and didn't even attempt to sync itself to the cycles at all. And another possibility is you could say something like this: I will meet you on the second Thursday after the new moon of the third month, and more or less you're going to get the same date unless you're right on those monthly boundaries. So there are definitely ways to get around
If
it.
it's concerning Chag HaMatzot, it can be 1 month now.
Say again?
If you, like I've had occasion where Rabbinical ask me, when is the Sukkot? And we don't know which the week is, and I don't know if it's going to be in 1 month or a month later.
Right. Sure.
So it's not just a day or two.
Right, that's right. In the case of the Passover, it could be. That's right. In the case of the Passover, it could be a month difference. So again, there has to be some kind of other system of counting, which is used to set exact times when they're not supposed to be based on the cycles of the moon and the sun. Jack, you have a question?
Well, the person on
on the computer,
Uh-huh.
when people ask questions, can you repeat their question and then
Sure.
answer it?
Sure, absolutely. Is
So
there a question?
whatever question people ask,
Oh,
so that people on the InSpeak can
I
know,
got you.
know
When the
that.
person asks a question here, to repeat the question before I answer.
Yeah.
Oh, understood. Will do. Okay. Okay, any other questions at this point? Or any other comments? Okay. Okay, so, let's see, let me just open up. Let me just open up.
No, but he looked it up.
I know that, but I'm just trying to, it was like, well,
You can just see, like,
oh, that's it, I didn't, programs that follows the enough. It's not easy to just do a control,
How about tackling and get a pole or something?
He would know what to say. Couldn't stop. He'd be like, somebody's talking about him.
And that is not.
Yeah. You know, some people use that kind of answer, and it's really neat for the
Okay. All right, let's talk a little bit now about, I just want to do a kind of overview of lunar and solar astronomy. Okay, so you can see where the problem arises from.
So, is the Karaite scriptural calendar mostly an observed lunar calendar?
To be precise, it's an observed luni-solar calendar. It's an observed luni-solar calendar. Okay, that's what the Karaite calendar is. Again, for lack of a word, Karaite or biblical calendar is more constant. And the rabbinical calendar is a calculated luni-solar calendar. Okay, so biblical calendar is an observed luni-solar calendar. And the rabbinical calendar is a calculated luni-solar calendar. Okay? Alright, so what we're going to talk about right now, do you guys want to take a break maybe for 5 minutes and come back, or should we go? Again, I just want to, be very much in tune with the group, what everybody wants. Should we go on? Okay? Alright, after this section later on, I think we'll maybe take a break for 5 or 10 minutes. Okay, so what we want to talk about is a little bit about lunar and solar astronomy. Okay, and the reason we want to talk about this is because we want to understand what the problem is. Okay, what's the problem? Why can't you just come along and predict and very easily make an observed luni-solar calendar? I'm sorry, a calculated luni-solar calendar. Why couldn't the rabbis or the Babylonians or the Chinese, okay, come along and say, we have no problem. We've got this all calculated out, and our calendar is accurate and stays accurate over long periods of time. Yes, sorry, Sam.
The orbit is a split planet circle, so it changes all the time.
Say again?
The Earth orbits in an eclipse, not a circle, so the orbit changes all the time.
Exactly. Okay, in an ellipse, right? That's the first thing we're going to talk about. Okay, we're going to talk about, let's bring it up here, 1 second. We're going to talk about Kepler's 3 laws, okay? Okay, so the famous astronomer Johannes Kepler, who lived more or less in the end of the 16th century, beginning of the 17th century CE, came up with with 3 famous laws, and they're called Kepler's laws of planetary motion. Just bring them up here. So the first of the three laws is Kepler's three laws. Planetary motion. First of the three laws, okay, is that all the planets revolve around the sun, not in circles, as many people have thought beforehand, but in ellipses. Okay, planets revolve around the sun in an ellipse. Okay, so for instance, if we were to take the Earth-Sun system, here's the sun. Okay, and this is what people thought before, not that long before, because obviously first they thought the Earth was at the center of the universe, okay? But at a certain point, when the heliocentric model of the solar system began to gain popularity, people assumed that the planets moved around the sun in a circle, but it turns out that's not the case. Okay, what do they actually do? They move around the sun in an ellipse. So really, it doesn't look so much like this as it does like this. I'm exaggerating it. Okay, but that's what the orbit of the Earth around the sun looks like. Okay, and the sun is at what's called the focus of the ellipse. Okay, I won't get into all the details of ellipses. Maybe some of you remember the high school mathematics. Okay, the focus of an ellipse is one of the primary points for determining the actual shape of the ellipse. And the Earth and all the planets go around the sun in an ellipse rather than in a circle. Okay? That's the first of Kepler's laws. The second of Kepler's laws is called the law of equal areas. And we'll see why this is very important. Okay? The law of equal areas says something like this. Here I have my sun. Here I have my Earth going around in an ellipse. Okay? And the second of Kepler's law says that the Earth will sweep out equal areas in equal times. Okay? What does that mean? Okay? If I were to consider the Earth starting here, let's say the Earth is going in this direction, looking from above, down the North Pole, okay? And the Earth ends up in this position, okay? In that time, it sweeps out a certain area. This area right here, okay? We'll call that A1. Okay? If I take any other two positions, and I make the area that's swept out between those two positions the same as A1, and I'll call it A2, okay? Then the time for the planet, for the Earth in this case, to sweep out that area would be exactly the same time as from here to here. And I'll explain what I mean because I know how people enjoy their high school mathematics, so it'll probably take 2 or 3 times to go through to explain exactly what I mean. Okay? If you see here, okay, this whole region that I shaded in makes a certain area, right? Everyone remembers what area is, I'm sure, right? A certain region that it takes, okay? And let's say, I don't know what it is, let's say it's, I'm just making it up, let's say it's 5 square centimeters. Okay? This region over here may also be 5 square centimeters, or we'll assume for the sake of argument that's also 5 square centimeters. How is it possible that this region, which has a certain shape, is 5 square centimeters, and this region, which has a certain shape, is 5 square centimeters? Because they have different lengths and they have different widths, right? The area, in the end of the day, is more or less a function of length and width. Okay? So here it's wider, but it's shorter. Here it's skinnier, but it's longer. And when you calculate the area, both of these areas are the same. Okay, everybody with me so far? Okay? Now, Kepler's second law, the law of equal areas, says that a planet now moving around the sun is actually gonna sweep out, meaning it's gonna create this A1 region in the same time as it will create this A2 region. Okay? What does that mean? Okay, if the planet goes from here to here, and let's say, again, it's all just numbers I'm throwing out, let's say 1 second, so we can make an actual count. It goes like this. In 1 second, it goes from here to here. Okay? Then from here to here, it's also going to go in 1 second. It's going to go, okay? What's the difference? From here to here, it's going much farther around in its orbit than it is from here to here.
The distance between where the Earth is and the focus of the orbit.
Exactly. It's going to be a function of the distance between the position of the planet and the sun, or the focus of the ellipse. Okay. If we're closer, okay, if we're closer to perigee means the closest position between a planet and the sun, then it's going to sweep out faster. It's going to go through that area faster. And if it's farther away, okay, if it's at apogee or it's close to apogee, then it's going to sweep out more slowly. Okay, what does that mean? Okay, the bottom line of all this means that what we get is not just a regular circular motion where the Earth is going around like this. What we get is we get speed up near the perigee and we get slow down near the apogee. So it's really going to be looking more like this. It's going to go whoosh, and slow down, then whoosh, and then slow down, whoosh, and slow down. Almost like a comet, right? If anyone's watched programs about comets, you always see the comet kind of come in, whip around the sun, right, and then whip back out. Why? Because the sun is actually also the focal or the focus of an ellipse on which a comet is. The ellipse just happens to be extremely large. Okay.
Is that because of the gravitational force?
Everything is because of the gravitational forces, right? And that's what Newton came along later, and then he developed the law of universal gravitation, which said that what's really going on is you have two opposing forces which are causing essentially all the orbits and all the motions of the planet, right? You have the gravitational force, which is a force of attraction, okay, and you have the inertial force, which is a force it's a force that wants to allow the planet to keep its or any heavenly body or any body to keep its same velocity, right? So inertial force means that if I give this tape thing a push, it keeps on going in the direction I pushed it, right? What slows it down? In this case, what slows it down is friction, right? If you may remember your high school or college physics, right? So in this case, you have two opposing forces: the inertial force and the force of friction, which slows it down. Okay? If there were no friction on this floor were made out of ice, and I gave this piece of tape a push, what would happen to it? It would go on for a long time, right? And if this were out in space and I gave this thing a push, and there was no significant gravitational forces in the area, then it would just go on forever. I could give it a single push, and eventually it would reach out to Pluto or wherever the case would be, right? So that's exactly what's going on in the case of orbits. Okay, if I have the sun here and if a planet here, let's say the Earth here, okay, the Earth wants to move in this direction, okay. And the gravitational force of the sun pulls it in this direction, okay? And what happens is the combination of these two forces, okay, actually makes it go in this direction. Well, now it's changed position. Now the planet wants to move out in this direction, but the gravitation pulls it in this direction. So it actually compromises and goes like this. And it keeps on doing this, and what happens is it ends up making an orbit around the heavenly body. And this is all due to those two opposing forces of gravitational attraction, which pulls it in, and inertia, which just wants to make it continue in a straight line, okay? And if we had time, we could go into all this mathematics. It's very fascinating on the mathematical level, but yeah, that'll be another, that'll be the detail, in the more detail, okay? At any rate, so the point is, Kepler's second law. Second law, okay, we get fast sweeps around the perigee, and we get slow sweeps around the apogee, okay? Question, how does that complicate our calculation of, let's say, the solar or the lunar calendar? Any ideas? Yeah. Why is this relevant to what we're talking about, calendars? How does this complicate our calculation of the calendar?
We can't predict it.
Okay, well, actually, it turns out we can predict these motions pretty accurately.
But there's got to be adjustments that have to be made.
Right, there are always adjustments that have to be made. Okay, any other ideas? It's kind of it takes a little bit of thought.
It also has to do with the rotation of the Earth that is doing this, the polarity and its own motion in the direction going around that creates another complicated calculation.
We'll talk about in a second. You're talking about probably the precession of the axis, and we'll talk about that. Okay. But there's a much more straightforward and simple reason, and I'll try to explain it. Oh, good, it's not picture. And the reason is this. Let's say I have the Earth here. I'm sorry, let's say the Sun here. And I have the Earth over here. Okay? And I have the Moon over here. Okay? We are now, the way I've drawn it here, we are now in what phase of the Moon would this be? This is the Sun.
Or the conjunction.
The astronomical conjunction, right? Not a full moon, it would be actually a new moon, right? We look towards the sun, we don't see a thing, right? We don't see the moon at all, okay? A full moon would be over in this position. We look out towards here, and we see the moon backlit by the light of the sun, okay? By the way, if the moon is over here, and the sun is over here, why don't we always get in place? Shouldn't this be the case? That the moon is blocking off the light from the sun, and we should always get an eclipse. But we don't, right? We don't get a solar eclipse every month. We get a solar eclipse only once in a while, right? And the reason is that and again, this is just goes to show how complicated the motions are. If this is the Earth, the moon doesn't, and this is the sun, right? Let's say that window is the sun, and this is the Earth. The moon isn't moving like this around the Earth. The moon is actually has a slight inclination. It moves like this, okay? So when we have the new moon, when we're in conjunction, and we look out to the sun, we're looking out in that direction, but the moon is up here. We don't see it anyway because the moon is so close to the sun that the light of the sun blocks everything out, and it's lit from the back anyway, so we couldn't see it. But once in a while what happens is that the moon, as we see, since it's going up and down, sometimes it will pass the line of the Earth, okay, what's called the ecliptic. Okay, it will pass the line that connects, or the plane that connects the sun with the Earth. And if that happens while the moon is in front of the Earth, or between the Earth and the sun, that's when we'll get our solar eclipse. Okay, so we have something like a situation like this where it comes down, and just as it comes down, it knocks into position between the Earth and the sun. That's when we're going to get our solar eclipses. Okay, but getting back to this. Okay, so we have a situation here where this is the sun, this is the Earth, and this is the moon. Okay, we're talking about astronomical new moon. At this point, again, if we're doing this in 3D, the moon wouldn't be right on this ecliptic plane. It wouldn't be right on the plane between the Earth and the sun. It would be up a little bit or down a little bit. Okay. At any rate, what happens? A month passes. Okay, the moon goes around the Earth once. Okay, a single month passes. But in that time, what happens to the Earth? The Earth isn't standing still, right? The Earth is also moving in that time. So now the Earth is over here. Okay? So the moon has gone around one time, and now it's back over here in the same position. Okay? Is this an astronomical new moon? Are we back in astronomical new moon? Anybody?
1 month has occurred, yeah.
1 month has occurred,
But the angle is over.
exactly. We're off on the angle, right? You can see it. If we look towards here, okay, that's the direction of the sun, but the moon isn't between the Earth and the sun anymore. The moon is a little bit off here, right? So what happens is the Earth actually has to go a little bit farther. I'll exaggerate this so we don't run into problems over here. The Earth has to go a little bit farther to give time for the moon to catch up. And now, all the way over here, the moon is going to be caught up to the sun, okay? This, by the way, is called the synodic period of the moon, okay? Which means the time from when I look outside the sky, and I can see it but calculated, okay, where if I could look out in the sky and see the moon, I would see it right in line with the sun. So the next time when I look outside to the moon, I see it right in line with the sun. That's called the synodic period of the moon, meaning synodic comes from the Greek root sin, which means the same, and nodic, which means node. A node means a phase, right? A phase or a point of the moon's phases. So synodic period means a time where from one phase to the same phase of the next month. Okay, or in other words, from one new moon to the next new moon, or one full moon to the next full moon, or one quarter moon to the next quarter moon, etc., etc. Okay. So what complicates this? Okay, we see once again, that the Earth has to do a little bit more motion for the Moon to catch up. Okay, but we said also before that we have the second of Kepler's laws, which is that the Earth is not really going around in a uniform speed here, right? It's slowing down here and it's speeding up here. It's slowing down here and it's speeding up here. Okay? So let's say you had a case where it was moving at a very slow rate. Okay? The Earth goes from here to here. Okay? And then it needs a little bit of extra time for the Moon to catch up, to get it back into conjunction with the Sun. But since it's moving slow, the Moon doesn't have to catch up that much because the Earth hasn't changed position so much in that 1 month, right? Is everyone catching on? Okay. But if we're over here, okay, the month passes, the Earth goes from here to here, and it's moved a heck of a lot around the circle, right? It's going pretty fast around here, and now the Moon has to take more time to catch up, okay? And so you get each month the catch-up time that the Moon has to do changes depending on whether the Earth is moving slowly around the Sun, if it's an apogee, or whether the Earth is moving quickly around the Sun, if it's in perigee, if it's closest to the Sun or farther away from the Sun. Okay? Again, if the Earth is moving slowly around the Sun, then the Moon has to play less of a catch-up game. And if the Earth is moving very quickly around the Sun, then the Moon has to play more of a catch-up game. Okay? Is that clear to everybody? Okay? And that's one example of many examples of what makes these calculations so difficult. Because this synodic period of the Moon changes each month. Okay, it's going to be shorter at apogee. Apogee means where it's farther away. I always remember because it's reversed. Farther is. I always remember that perigee is closer. And apogee is farther, but it's reversed from perigee is a P and apogee is an A. So always remember it's the opposite of the regular order. Okay? And when it's closer, at perigee, it's moving faster. Here it's slower. Here it's faster. Okay? So here you have more catch-up. And more mustard. And here you have less catch-up. Okay? And therefore, the synodic period of the Moon is going to be less here, and it's going to be more here. The time that I see one new moon until the time I see the next new moon is going to be faster at perigee, and it's going to be more at perigee, and it's going to be less at apogee. Okay? Is that clear? Everybody understand that point? Okay? What does that mean? I'm going to bring this up. Just get all the numbers up here so we can talk actual numbers. The synodic month the time from one new moon to the next new moon, and one full moon to the next full moon, could be anywhere from 29.27, which is about 29.25 days, synodic period, up until 29.83, which is greater than 29.75 days. Okay, that's the synodic period. Okay, one new moon to the next moon can be as short as 29.27 days, or it can be as long as 29.83 days. Okay, and it has an average, which is called the average synodic period. Synodic period, or sometimes it's called the average lunation. Okay, which is going to be somewhere between this minimum and this maximum. And that average synodic period, or average lunation, as calculated, oops, where did we go here? Where my nice numbers go? Here it is. So the average synodic period is going to be 29.530588 days. 29.530588 days. okay? Which we can see is more or less in between, right? If this is 29.25, and this is a little bit more than 29.75, 29.53 is about 29.5. It's a little bit more than 29.5 days, right? So this is the average synodic period. This is the minimum synodic period. This is the maximum synodic period, and this will change over time as well. In another couple thousand years, these values will actually change, because not only are things changing in space, they're also changing in time. Okay, the changes are minor. Okay, what actually is happening is the moon is actually pulling away from the sun by a couple centimeters every year, and when it pulls away from the sun, it actually slows down the orbit. So these numbers are going to go down over long periods of time. It's minimal, but the point is that everything is constantly in flux. Everything is constantly changing, right? You look outside, or go for a walk in the woods, and you see that nature's not standing still. It's constantly changing. Things are growing and dying and being born and changing color. And yes, Bill.
The elevation of the orbit also changes, right? Not always constant elevation.
You're talking about the elevations of the moon's arc?
Yeah, the moon's arc and the sun, Earth's arc around the sun is always in a flux. It's not just a straight line, fixed orbit.
Right, I hear what you're saying, okay, and we have to be careful. We will talk a bit more about that, okay. The inclination of the moon's orbit with respect to what's called the ecliptic plane, the sun's plane with the Earth, is approximately 5 degrees. Okay, slightly elevated by 5 degrees. Okay, but that number is not changing. Not that I've read, not the research I've done. But what does change is because it's going up and down, the angular position of the moon above the ecliptic is constantly in flux. And that's what I was saying before. If we get a situation where the angular position of the moon with respect to the ecliptic is 0 degrees, meaning the moon is on the plane which connects the sun and the Earth, then we get a solar eclipse. Okay, if it's up or down, then we don't. And that's constantly changing because the orbit, the ellipse of the moon around the Earth is changing on its axis as well. Okay, so the moon is not just going around like this. It's almost like, remember this game Spirograph, right? It kind of goes around and around and around, so it's constantly changing. It's always on 5 degrees, but the orbit is rotating, and sometimes it will just get in line with the sun when it happens to be right on the 0 position, and then you'll get an eclipse, and sometimes it will be above, and sometimes it'll be below. Okay? Yes, question.
Are you getting questions?
Yes, ma'am. Certainly am.
Okay, Caleb asked what's the practical relevance, but I know it's asking the same question for the spiritual question.
Okay, yeah, that's. We're getting to that. That's going to be the main thrust of this. I see everyone's impatient like that. But what is? Let me answer the question now, and then I'll say that this is going to be the main thrust of what the lesson is all about. Okay. The answer to the question is that because these periods are different, because the synodic period of the moon is different, for an example, and other periods are different as well, okay? Because the synodic period of the moon is different each month, okay? Whenever someone attempts to set a fixed calendar, they run into problems, because they can't say, okay, the time from this month to the next month is exactly 29.5 days. It's not. First of all, we see it's even on an average 29.53058 days. It sort of makes things complicated. But then each month, it may be more than that, or maybe less than that. So any kind of simple calculation in setting up a calendar is not going to work. Or it may work, but it's not going to hit everything exactly. Okay? So the bottom line is, the calendar tries to set up a practical system for man to make predictions about astronomical events and stay in sync with those astronomical events. Okay, but in practical application, it's very difficult to do because the heavenly bodies are not moving around in simple motions. They're moving around in very, very complicated motions, and that's what ultimately causes calendars to not be accurate to begin with, and then to even suffer from calendrical drift over time. And that's why, and that's exactly why a calendar of calculation, such as the Rabbinical calendar, is a less viable calendar. A calendar of observation is a more viable calendar. And that's the bottom line to this entire physics lesson. Okay, I hope I answered the question.
I
Okay.
answered that.
Should we take a break I think we should take a break maybe for 5 minutes? Okay?
Yeah, or a little bit longer, if you want to answer a little bit of questions first.
Sure. You guys answer questions, we'll take a break for...
You want me to pause it? No, well, what I want to do is answer questions, and then we'll take a break for lunch.
Sounds good?
I wanted you to get kind of close to the end of the tape, and then so if you want to go ahead and stop and answer questions now, for about, 15, 20 minutes, and then we'll stop the tape, and we'll take a break for lunch, and then come back.
Okay, why don't I answer a couple questions, and then we'll take the break, and then we'll come back.
Okay. Okay, so Caleb is asking, so our Creator Yehovah wants us to depend on Him and be obedient to His time. To His time.
Right. Well, I suppose in a simple in a simple answer, yes, right? Because we have what we're supposed to keep are the Moadim, the word Moed, which is usually translated as the point of time. Okay, we'll go into Hebrew a little bit. It's usually translated as the appointed time, but that's a very poor translation. Okay, a Moed really means a meeting time, a time of meeting. Okay, even in modern Hebrew it's used this way. Okay, like if I miss a meeting, they could say Nikva Moed Chadash. Okay, we'll make a new meeting time. Okay, we'll set a new meeting time. Moed. Okay, it means a meeting or a meeting time. Okay. So the idea is that on these Moedim, on these what's usually translated poorly as appointed times, the idea is that we meet with Yehovah. We're meeting with God, right? God comes to greet us, and we come to greet Him, and we kind of celebrate together. Okay? Therefore, in order for any two people to meet, or any group to meet, you need a time and a place, right? The place is Jerusalem. The time is the time of the Moedim. Okay? And so therefore it's very important that we be accurate on these times, because if we show up and God's not there, or God shows up and we're not there, we miss the meeting, right? So then you get into the whole idea of okay, well, how, what is the accurate conception of the accurate definition of the Moed? When should it exactly be kept? And the ancient biblical calendar basically was founded based on observation. Because that created the most accuracy. Because you look out and say, hey, it's a new moon. It's time for me to it's the new moon of the 7th month. It's time for me to go meet Yehovah and celebrate Yom HaTruah with him. Okay. Or hey, the Aviv's out. This is the month of the Aviv. It's time for me to this month to bring the Omer offering and eat unleavened bread for 7 days. Okay. So reading the heavenly bodies has always traditionally been a way to set meeting times, right? And that's alluded to explicitly in Genesis. I don't think it's there first, but we can look at it later in Genesis chapter. I think it's in Genesis chapter 1, right? Where it says that the big light, the sun, and the small light, the moon, were put in the skies for Chodeshim and Moedim, for months and for appointed meeting times, etc., etc. Right? So the Tanakh already implies that we're using these heavenly bodies to read these times off when we're supposed to meet with Yehovah, right? So that's a basic idea of the biblical calendar. That's a basic idea of the Karaite calendar, which is essentially tries to be the biblical calendar, which is to use the heavenly bodies to read the skies and read the stars to set the Moedim, so we know exactly when these meeting times are with Yehovah. That's the basic bottom line. The rabbinical calendar. For various reasons, and I'm not criticizing the reasons they went off that. I criticize the reasons they stay off that to this day and age. There's no reason that it should be now, but it's understandable why, given the situation back then, that they had switched over to a calendar calculation. But once you switch over to a calendar calculation, you're no longer reading the events from the sky, right? You're basically God's signs in the sky. You're not reading them anymore. You're trying to predict them, and once humanity tries to predict the signs in the sky, you run into a lot of problems, and hence the physics lesson, because I want to show exactly how difficult the motions really are and how difficult it is to really predict these points of time as we go ahead and try to do it. And that's really the answer to the question. Okay? So we'll take a break for any other questions?
She just had one more question.
Yeah.
Okay, I just read it instead. She says, so why are the Karaite Jews not in Jerusalem now?
it depends which Karaite Jews you're talking about. Why am I personally not in Jerusalem?
I don't know.
I have personal reasons that I will be going back to Jerusalem hopefully next summer, maybe a little bit later. But I'm not in Jerusalem right now because I need to make money because I want to set up a Karaite community back in Jerusalem. And unfortunately, Israel suffers from dire poverty among most of its population. Michal and myself.
Teleporting hasn't been perfected.
Caleb, and go right off the mic, and then Caleb can come to the mic and ask.
Sure.
My observation is we didn't take as much time and effort and planning and saving and all of it does to, to make Aliyah for those that are Jews. Anyway, this is the power. It's not simple, I'm sure it's not. It's a big deal.
Okay. I think it's a comment, so it's not a question. So I won't answer it, but I'll say I think it's an excellent point, and I think that at some point in the future, those who are really serious about being part of the nation of Israel have to live in Israel, and I think that at some point becomes a litmus test. Okay, if not at this moment, but at some point, someone's willing to pick themselves up as say Ruth did, right? When she went back to Israel with Naomi, and she was willing to pick herself up and leave her community and leave her family and leave her gods, etc., and prove her dedication to this way of life and to the God of Israel, Yehovah. Then that kind of becomes a litmus test. But I don't think. On the other hand, in the case of Caleb, I don't think she said it's not easy. That doesn't mean that everyone can just tomorrow pick up and fly the next plane to Israel and set up their lives in Israel, as even Ruth didn't do it immediately. When the time's right, when the place is right, then those who feel the calling will do it, and those who don't may choose to kind of stay in the background and worship Yehovah from afar. It's kind of ultimately becomes an individual decision. Any other questions? Okay, so we'll take a break now, and we'll convene afterwards. Yeah? Okay. And if anyone wants to ask questions on a one-to-one basis,